Hi everyone, welcome to the Deep Learning for Natural Language Processing course. In this lecture, we'll talk a bit about some topics that are getting quite a lot of attention in the last couple of years. Bias and ethics, a short version of it, of course, and then we'll try to explore some of the alternatives to have a responsible use and report of AI and AI tools, right? Starting with bias and ethics, it's probably a good idea to have a disclaimer that this is a pretty much a short version of bias and ethics and AI, and more specifically in natural language processing. Since they are both two really complex subjects, we'll try to give an overview on the most important aspects. Okay. So far in the natural language processing course, we have been studying a lot of things. For example, text representation, we went over syntax, how to extract semantics, how can we embed semantics and words into word vectors, sparse vectors, dense vector representations. Then we start talking about some neural network architectures, went over some natural language processing tasks such as machine translation, text classification, word disambiguation, language modeling, and so on. However, there is another aspect behind the technical things in natural language processing that we should be aware. But before we get into this, let's try to take a look on all the elements that we went over through the entire course. So when we look at data, text data, decision making, intentions, pretty much what all those things they have in common. If you think for a moment, you see that from the data to the actual decision making, for instance, we do have a huge impact in our society. Either we want that or not. So depending which data you use to build your machine learning models, or what kind of text data supporting whatever decision that you might have, all of this, it doesn't end simply with a final classification, right? Things go way beyond that, and we should definitely be aware. In that direction, one of the things that we should mention about, and unfortunately, not many computer science courses they touch this, but it's getting quite a lot of attention in the last couple of years. Is about ethics. So into from the introduction to ethics from John Day, we have this quote that is quite interesting. Ethics is a study of what are good and bad ends to pursue in life and what is right and wrong to do in the conduct of life. It is therefore, above all, a practical discipline. Its primary aim is to determine how one ought to live and what actions one ought to do in the conduct of one's life. And this is quite interesting because one might think that ethical aspects they are rather theoretical, but at least in natural language processing, you see a direct application of those huge or those large language models being used and or perpetuating some sort of bias or false information or misinformation. And these things we should be aware. Also, what does it mean when we're using a certain data distribution to build a given model? What is the implication behind that, right? But we'll get there. So when we talk about ethics, mainly we're talking about things that are either good or bad, right and wrong, and these are really deep concepts, deep topics, and they, of course, they need to be discussed not only in computer science but any other area. Uh, that being said, we'll try to give some perspective on, what are things that at least we have been seeing the last couple of years that for sure affected some of the outcomes on models being proposed, and some of them had a really bad outcome, but the importance of discussing them is that we are aware and try to mitigate things that might end up bad. And for that, by the end of the session, we'll go over some approaches that they try to at least bring some more transparency, responsibility, liability, and so on to the models, data, and tasks that we divide. Okay? So, When we talk about ethics, think as a inner guiding moral principles and the values of people and society. It's quite hard to put this into a discrete structure or this discrete range. For example, we cannot categorize ethical decisions between as zeros and ones or black and white. This is quite hard to do simply because uh, between those two extremes, like 0, 1, we have a bunch of other numbers to describe things. And when we are trying to define our data, our tasks, and our models, things are pretty much the same way, right? So you have to take care which aspects you want to take into consideration. And for that, there is no easy answer. Like there is no recipe for you. Okay, if you collect your data in this distribution, if your data is this size, if it represents this and that, it's free of bias, for instance. This is quite hard to do, but we'll get to some of those alternatives. And not to mention that what is ethical and what is considered biased to some extent, it changes over time. It's not like the same idea that we had a couple of decades ago that things were somehow ethic. There still are. Much on the contrary, things they change over time, and the beliefs of people change over time. So things that might be accepted as correct or let's say as ethical or legal, nowadays we know that that's pretty much different simply because with time we evolve and we do try to make it better. At least this is what I believe. uh, Let me try to bring a more concrete example to this. So let's say we have this arbitrary table here with name, age, gender, stage, religion, and disease. And from that, we have a certain number of elements there with like this name right here, Yadu, 24 years old, female, she's from Kerala, religion's Hindu, and the disease is a viral infection. Imagine that if a certain company get their hands on this, or if we put this data out there available for everyone to use it, how we are propagating that certain decisions they might be made into aspects that they should not be considered. So hopefully you can see that, for example, the name is completely irrelevant. If let's say we want to give a rate for a healthcare plan for whatever person is here, so taking a look into this, we can imagine that okay, I can see that certain states or certain age or certain religion, they are associated with some sort of disease. So one might think, okay, every time I have uh, um, a Christian here, I have no illness, so I'm gonna give a cheaper plan to the person that's Christian. How can we, look at this and say, okay, let's try to make at least our model that's going to be ingested into whatever machine learning model there and try to either make things a little bit more neutral or try to prevent that certain aspects are used and on are used against the people that we have here. So one way of dealing with this is if we're interested to give a health issue plan, a health insurance plan to people, religion and name, they're not relevant characteristics for that. And therefore, we can pretty much anonymize the data. There are ways, if you have, let's say, other features to kind of find this other information that we missed, but for this simple example, that's not relevant. So also the age, instead of having a specific gender associated with a defined age, we can come up with some ranges, and all of this will help us to pretty much anonymize and protect the people behind this data. Needless to say, we also prevent that this, let's say, bad decisions are made simply because of the data selection that we have. I mean, there is no way to guarantee that this data here is extensive to the entire world. So my beef that for this sample that I'm using to build my model, I have that all male, gender male, uh, personnel here, they are associated with some sort of a disease, but in the vast majority, that would not be the case. And you might think that, okay, as an illustrative example, that flies really well. But what about a more concrete example? Let's say, well, for that matter, I'd like you to take a moment to read this abstract right here, and let's try to highlight some information here. So this is an abstract that we have for a paper in which they reported that faces contain much more information about sex orientation, and then that these features were entered into logistic regression aiming at classify sexual orientation, and given a single facial image, a classifier could correctly distinguish between a gay and a heterosexual man in 81% of the cases and 74% of the case of the women. Human judges achieved a much lower accuracy, and then we see that here they even say that prediction models aimed at a gender alone allow for detecting gay males with 50% accuracy, and so on. This quite complicated statement, and you might think, well, okay, this probably is from a research done, I don't know, 1900s or something, I don't know, 1960s or 70s or even before that. Well, unfortunately, that's not the case. There's this abstracted from a paper called Deep Neural Networks Are More Accurate Than Humans at Detecting Sexual Orientation from Facial Images. And this was published in 2017. Just to give you some perspective how the data or the text in our specific case for NLP can be used to devise some really, let's say, not ideal correlations and definitely bias findings. Uh, just some just some paper details that we have here. So their research question to start with, just, and by the way, we're going to go over this paper details to show you how you can have a problem, either an ethical problem or a bias problem, and every single instance from, in this case, the scientific process or the actual problem that they are allegedly trying to perform better. In this case, the research question is identification of sexual orientation from facial features. That alone already is quite a red flag because you do have a really polemical research question that it should have been a better, well taught and considered. And if we put that aside and take a look on the actual technical aspects of this paper, we start finding something quite disturbing. For example, in their data collection, those photos that they use in their system were downloaded from a popular American dating website, and it was composed around 35,000 pictures for around 14, almost 15,000 people. Uh, were all white with gay and straight, male and female, all represented evenly. So that alone already opens an entire discussion about their data quality, data bias, and so on. And then their method was simply to define a deep learning model to extract these features plus grooming features and then feed it into a logistic regression classifier and perform this classification for gay and heterosexual men and women. And they're between quotes successful, and this accuracy report was 81% for men and 70% for women. So hopefully on the methodology you can already see how that's problematic to put such a complicated construct into a simple logistic regression in a hope that this is enough to work as a classifier, which is already alone quite complicated topic. Well, just a summary here. So some of the many problems with this in this technical details, as we saw, is only white people were included. Definitely specific and certain social groups, certain age groups, and a time range, fashion, and so on. So also, just to highlight what they said in their paper, sexual orientation detector. So using just 35,000 images, From a public profile in a US dating website, they're able to construct this classifier, right? Not only that, there is another topic that we did not touch much. There was no space to mention the abstract, but the link for the paper, it will be included here. That consistent with the prenatal hormone theory, PHT, of sexual orientation, gay men and women tend to have gender atypical facial morphology, not considering all the problems, the ethical problems with the definition of the research question and the impact of that research question has on people, the data, and so on. They also found a correlation that is actually not ideal for this scenario. I mean, based on their cherry-pick findings, on the cherry-pick data sets, they find out that this correlates with another cherry-picked example. If you want to know more about this discussion, there is this Medium post that is definitely worth to take a look at it. Okay. Well, needless to say, these things, they do get a lot of immediate attention, of course. The same way that now AI power tools, language models such as ChatGPT are getting a lot of attention from media by they claiming that yes, artificial intelligence has suppressed humans in all the areas, and now they're going to dominate the world. Of course, the same happens when there's topics as sensitive as bias and ethics. So this particular paper got a lot of attention in media back in 2017, in which facial technology reported advances in AI are used to spot signs of sexuality. Then a guest post on artificial intelligence discovered a face. AI can't tell you if you're gay or not, but it can tell you if you're a walking stereotype, and so on. And all of this is just to show how this allegedly naive paper, let's believe that this was done from a naive perspective, have a lot of implications. Imagine that if you extrapolate their findings to places where, let's say, a specific choice can affect your life forever. So this is quite disturbing. So if we look to the potential misuse of the results of these papers, and by the way, as you might be aware, this paper is definitely not the first, and most likely it won't be the last one that does things like this. So in the past, we had several papers doing correlations that are today completely spurious. For example, I don't know, soda or drinks, sugar drinks. They report that if you do enough sports, that's enough to counterbalance whatever bad effects that consuming a lot of sugar drink has. But in any case, let's go back to the main topic. So, what are some potential misuse that we have here? So, how can people be harmed by this research? This is actually a question that will be used later on for us to assess the use of AI. But in this case, the effects of this research topic in many countries, for example, belonging to a certain sexual orientation, is prosecutable by law or by society, and even in some other places, this can even be punished by that. So a simple paper, let's say, I don't want to call it simple, but this paper and their findings, they could have huge repercussions. So we should also have that in mind and do this exercise to think, okay, what kind of group is being affected by my findings here? Or I'm looking at this data. Is this data really representing the reality, or is this data diverse enough? Or considering the groups that I want to target, is my data diverse enough so I can represent them in a fair manner? So not only that, this and other findings, of course, they can affect people's employment, family relationships, healthcare and opportunities, and so on. So attributes like gender, race, sexual orientation, and religion, they are social constructs. And not to mention they change over time. So if you have something like this defined, imagine an institution or a research group release a list of, hey, these are the features that make a person to belong to a certain sexual orientation group. Imagine how that can be used for into bad decisions, right? All of these features they are related with people and they can be used against them. So we should be aware of that when we're building our own systems, not to propagate whatever, let's say, whatever bias or unethical outcomes out of it. Okay. Uh, I mentioned before, this is not the only example. So there was in 2016 then a paper called "Automated Inference on Criminality Using Face Images." It pretty much goes in the same direction, but then they use barely 2,000 images, cropped images of faces, and then they use that to identify that if a person is defined as a criminal or not. And then 6 months after that, the same authors they released a response to that paper called "Response to Critiques on Machine Learning of Criminality Perceptions." Uh, the paper is still available on archive, and they tried to come up with some explanations why they did that paper, and the idea was to evaluate the models available and so on. But still, as we are leading the way in research and we are working with systems that can be used that affect people's life, we should be aware how to better build them in a way that it will not affect negatively people out around us, right? So, uh, going more specifically now on natural language processing and text, there is a common misconception that language has to do with words and what they mean. A fact of the matter is that's actually not true. Words, they have to do with people and what they mean. So when we write a post or we write an essay or a Reddit thread or a comment on YouTube and so on, we are conveying our beliefs on that. And then when people or when humans they write something that is also embedded with all their beliefs, and if we use this data to produce systems, it's kind of a chain, right? So the decisions made by the systems that use the data wrote by people, they will bear all the bias and misconceptions and everything that's related with that to their systems, and this system is going to be used to make decisions. So we are pretty much amplifying whatever aspects that we are conveying in our text. Okay. Um, yeah, just to show how this can actually be uh, portrayed in a text, and sometimes we don't notice that much. Imagine that this is a famous case and it says, "Hey, a man and his son are in a terrible accident and a rush to the hospital and a critical care, and then the doctor looks at the boy and exclaims, 'I can't operate this boy, he's my son.' And then you'll be surprised if we ask, who is that person that says, who is the doctor that says that? It would be interesting to see the actual response to this, but on average, a lot of people get confused because they associate the word doctor with a male figure, whereas some other languages that they have a distinction between a male figure and a female figure, they would not make this mistake. So depending on the language that you have, you might be also embedding your own, let's say, cultural beliefs on that. And then also, of course, this doctor can also be this one right here, but let's skip that. And then another example on how ethics and bias they are related on our decisions. We can pretty much show the trolley dilemma. I think it was MIT, and I think this link here will point to MIT if I remember correctly. Um in which what happens if you have a train coming and you have to direct your train to either go there to the rail and kill 5 people, or go to the other one and kill 1 person if that person is, I don't know, a felony or whatever category this person might have. On the Bringing this more to an up-to-date example, imagine that you have a self-driving car, and then this self-driving car has in this road has two alternatives. One, to run against the wall and crash it, killing the driver and also the passengers, or um go into the other side of the road, protecting the drivers and its passengers, but killing a bunch of other people. So in this case, uh, what decision would be the best, if we can categorize as the best, which I don't think we can categorize the best, but who can we hold accountable for such decision? It is the model that the car was trained on, is the company that owns the car, or is the driver because he purchased that car, and so on. There is this really interesting game that you can play around and see, given certain scenarios between the people that you choose either to save or, in this case, to kill, it will show you how biased you are towards certain features and category of people, right? So when we talk about assessing AI, and we do this mental slash practical exercise to be aware of the characteristics that might result into bias or unethical systems, there are a couple of things that we can do. For example, we can evaluate the ethical aspects of research questions. So, what is the impact of technology and their potential dual use? This later we'll see that nowadays, at least from an LP perspective, there is a couple of methodologies or approaches used to kind of reassess and reevaluate the 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 impact of our data sets and models. But when we talk about the impact of whatever model or technology, we are interested to understand who could benefit from such a technology, or in this case, the system, who can be harmed by such technology or their results. Could sharing the data and models have a major effect on people's lives? So, as we share the data that was used to build those models, how this can affect the people using them. Also, privacy, who owns the data in the end? If the data is out there available on the internet and we use a tool to crawl that and feed that into a model, who actually owns that? Uh, Also, what is the difference between publish and publicize? So all data that is published, it should be actually be public or not really. How we can get the user consent and implicit assumptions of users regarding how the data will be used. This is something that some people are already trying to get their heads around it. It's not that trivial. Imagine that you're devising a system to help on clinical trials or clinical traits, and then you use the entire hospital data for doing that. How does one work on processing this data and make sure it's anonymized? And for instance, health insurance companies don't get their hand on that to, let's say, charge you more for a plan that you own. Also, when we talk about bias in models, how to control for confounding variables and corner cases. Does the system optimize for the right objective or the wrong objective, between quotes? Does the system amplify bias? Well, in this last question, most likely yes. Every time we're using an automated or slash an AI system to help us figure out a certain decision, we have to be aware that this relates with the concept of scaling. So the more data you have, the more evidence, the more you can scale your tool to use all that resource available. And then imagine that if you're encompassing with some sort of bias in this data, this will just get amplified because of that tool slash approach. Also, utility based on the evaluation, they should be beyond the accuracy. And on top of that, I would even add that this utility-based evaluation should be beyond on automated metrics. Depending on the task that we're using, you should have a human in the loop to make sure that whatever your model is producing, be that a decision or be that uh, let's say a given category, we should be evaluating that to see if that really makes sense or if it's really right to have this output. We should consider the impact, the real impact, not just on the metric of false positive and false negative rates. Sometimes is not that problematic to have a false positive, but a false negative can be devastating, or the other way around. In this case, let's say if you have an email that was categorized, a spam email that's not categorized as spam, but it ends up in your inbox, then it's not a big deal. You can delete it. But if you have a real email from a real person and that for some reason is categorized as spam, you might not see that email ever. So this is just a couple of examples how this can have some effect in our life. So why I think this question is more pertinent now than ever. Why is this becoming so important? Why assessing AI is becoming so relevant in the last couple of days? And it's aside from a bunch of political, economical factors, there is one that does call our attention, is that with great data comes great responsibility. As simple as that, because the more data you have, the more data is absorbing whatever content humans are producing and all their characteristics along them. And if you use that to build your model, well, you're also propagating all those characteristics, bias, and so on. The more user-generated content you have, the more tricky it gets to make sure that you have a good sample being represented there, right? On top of that, machine learning tools are everywhere and accessible to anyone. I mean, language assistant tools such as ChatGPT are there to prove that. And these things we should keep in mind. So the good thing is on top of all this complexity on how to handle misinformation or bias or unethical aspects or non-anonymous data and so on, all of this, although we are highlighting the concerns about it, there is a lot of people trying to cope with this reality. So there has been a lot of discussions, at least on NLP. For example, the social impact of NLP, design ethical challenges, the trouble with bias, asking the right questions about AI, AI usage cards. Also, there's a bunch of courses that now are incorporating this assessing of AI in their curriculum, and also a couple of papers and technologies that are right now being used. And this, we can give a spoiler on the class that's up ahead of us. There are pretty much in NLP a couple of strengths trying to tackle the assessment of AI from the ethical aspects on the AI tasks, the data sets used and produced, and the models used, and and at the end we also have how to use this AI tools, how to report the usage of it, and we'll talk about them later on, right? Before we talk about the alternatives and trying to mitigate or to diminish the amount of bias and unethical aspects that we have, we should at least have a good idea. When we talk about bias, it's kind of an umbrella term that you can have for certain, let's say, characteristics. The same way, for example, here in this case, we have bias data, and then we have reporting bias, which is pretty much what people share is not a reflection of real world frequencies. And we kind of see this in social media, right? What usually people report on social media are more related with good things than bad things. So this might be not a reflection of real world. So yeah, in selection bias, depending which data set that you might have, you might be cherry picking the data that will compose your model, and that might actually not reflect a random sample out of group homogeneity in the way that when we're outside a subgroup, we might see people or certain aspects from another group with less details. So we kind of group things together that do not belong to our knowledge or our group to something more general. And then confirmation bias, which is pretty much the tendency to search for, interpret, favor, and recall information in a way that confirms one pre-existing beliefs or hypothesis. This is the case that people look at clouds and start seeing specific animal forms there. So this is quite complicated. We try to search for these parameters even though they're not there. Just to give you an example, other areas they also have some sort of division and bias. For example, when you look at media bias, for instance, media bias is also an umbrella term that you have for different kind of bias, such as hate speech, political bias, gender bias, and so on. So it's just to show that this concept is an umbrella, not just for us, but for others areas as well. And then after we have our data on the interpretation side, we also have some some other kind of biases. Confirmation is pretty much the same thing, in which we are confirmed one pre-existing beliefs or hypothesis, then overgeneralization. So we come to a conclusion based on a limited information that is too general and also not too specific, and or not specific enough. Also, the correlation fallacy. This is probably one of my favorite ones, that we think and we tend to see correlation as causality, which is definitely not the case. And with the use of these automated tools, we try to fall into this automation bias quite often. I mean, how many times one or you have traveled to a different country or a different city, and while looking to restaurants, you got some restaurants, when looking for restaurants, you got some recommendations, and you pick that simply because that was automated, generated for you. Now, let's take this example and put to some more recent tools that provide text for whatever input that we have. We might be also more inclined to trust that simply because it was automated somehow, and we tend to believe that was the right choice, even though that might not be the case at all. If you know a bit on how those models are trained, you are aware that they also have a lot of biases and problems with them, and they perpetuate them over their use, right? So, just to give a bit more illustration, the scenario on the biases that we have for data and interpretation. In this case, right here, for example, let's say you're trying to, do a survey, and for that matter, you take a look, or you consider using Amazon Mechanical Turk because you want the users to label something. Thing is, sometimes selection does not reflect a random sample, even though by using Amazon Mechanical Turk, one might think, well, yes, I try to do this as agnostic as possible, but the truth of the matter is that most of, let's say, the evaluators coming from Amazon Mechanical Turk, they are located in North America, right here, and somehow in Europe, whereas all the others they're pretty much not considered. So imagine that you are trying to identify, let's say, the different word meanings into different countries, and then you run your Amazon Mechanical Turk and you find out that from a certain number of definitions of a word, just 2 out of X are the most used, and then therefore you discard the other ones, and you think that's a good representation. But if you look at that, entire countries and partial continent are not representative enough on that. So you have to make sure that whatever you're selecting, people in this case, to answer for a given survey, make sure that you somehow can mitigate things that will generate you a very picked sum. Okay. On data bias, a couple of years ago, probably you remember that Twitter taught Microsoft AI chatbot to be a racist. in less than a day. So this story here is quite funny, but it was actually the data that was used to do that. So even though the tool was allegedly not biased in any way, the data that was fed into this made the model simply replicate and amplify whatever trash data was given into. I mean, this whole thing about the quality of the data, it reflects in all the models that we use. There is no other way around it, and there is no magic around it. Garbage in, it will result on garbage out. Of course, you do have some manners to try to cope with that by trying to clean your data or trying to make sure every aspect that you are looking into is representative enough, but still the data quality that you fit in will be the quality of the data that you have out, just amplified. And out of the group homogeneity bias, just to show how we do have a tendency to see out of group members as more alike than inner group. So in this case right here, we see that we have certainly a bunch of different type of ants and bees, but each of them see each other as just one simple, let's say, a group illustration. Also, the representation bias, and then it's possible that you have an appropriate amount of data for every group you can think of, but that some of these groups are represented less positively than others. So how many times we found in a situation that given our sample, we usually benefit a given group, but simply because the data that we have, it is, let's say in this case right here, illustrating a group better than others. Okay, this was actually an issue a couple of years ago, and then things did got better. But it's important to mention how this was once a problem a while ago. If you were looking for specific words to find images like ceremony, wedding, bride, and so on, you most likely will get things on this side of the picture here on the left. And then photos with a different ethnicity, they would be categorized simply as person, people. So this would happen most likely because of the data that they use, and it was annotated that way. It doesn't make it right though, but depending on how you annotate your data, this will reflect the views that you have as an annotator. And this, needless to say, can be quite problematic for representativity and other related issues. Confirmation bias. So this is definitely one of my favorites. That how many times we have a certain, let's say, belief, or we have a certain set of confirmation beliefs that we believe to be right, and then by simply, looking around, and the first thing that supports our argument, we use that to say, well, that's true because I found something that confirms that. So it's not just because you found something that confirms whatever belief you have that make it right. Then overgeneralization bias, it's somehow related with out of group in a way that we try to oversimplify some decisions, especially in data, if we don't have the entire picture. So in this case right here, we have a dog saying that all cats have 4 legs, and I have 4 legs, therefore I am a cat. So it's not just because one set of categories, or let's bring more to a real example. Let's say you have a certain number of metadata or features that they overlap with others from another group, that you can overgeneralize them into or from on the same let's say bucket, right? Then looking into correlation fallacy, especially when we start plot things, we try to find that things are correlated somehow. So in this case right here, for anyone that was a kid during the 90s, you probably remember on the early 90s, remember that how it was portrayed that violent crime is related with video game sales, saying that was the reason why people had more violent crime. But truth is, things are not that simple. We wish they were, but definitely it's not the case. So try to take care, especially when you're reporting your results and you have those nice curves and they do overlap somehow and say, wow, this is really correlated. Make sure that whatever finding you have right now, it is being carefully analyzed. Make sure that the variables are indeed not affecting another, and also that somehow you're not simply overlapping your finds and using that as a justification to make sure that two aspects they correlate one to another. Another interesting example, though, is that the number of people who drowned by falling into a pool, and it's quite correlated with the films that Nicolas Cage was on. This is quite funny, but in any case. Automation fallacy, as we're saying, how many times we looked into restaurant recommendation, and that recommendation simply because it was provided by a rating algorithm based on whatever people around me or my preferences, uh, make us try to choose that recommendation simply because it was automated generated. And this happens also with other systems being used. For example, if you're using a software to correct your writing, most likely you're going to be adopting the sentences or the word inflections from this automated tool simply because you think that will provide the best answer for you. Uh, Another problem that we saw when we're talking about machine translation, and this usually happens more with low resource languages simply because you don't have enough resource to provide a more complex model to categorize or let's say to describe the characteristics of your language. So for low resource languages, you have something like if you just change the profession of that person, you'll see that certain pronouns they will be categorized as one profession, but by changing the profession using the same pronoun, they're translating to something completely different, which is somehow alarming. This also happened with other languages like Finnish to English, in which by changing again the professions, the pronoun will change quite a lot simply because of the data that they have there. And this is pretty much to show you that from the entire process on the data collection through the entire, let's say, output and drawing conclusions about it, where we can actually have human bias, be that on the interpretation of our results or the data that we're using. Uh, one might say that human bias already starts when you're training your data, when when you're collecting your data, you're cleaning your data, you have bias right there. And then some people might say that between the model training and also the whatever data that is being filtered, ranked, aggregated, and correlated, we have human bias. But the truth is, human bias is present every single step of the process. By the moment you define your research questions, the moment you define your methodology. So it's quite tricky to say that, oh yeah, we should remove bias. This is, at least on my perception, this is somehow impossible to do. You can mitigate some bias aspects, or more important than that, which I believe you should report what kind of biases or ethical concerns it might have in your system. Um, so, just to have this summarized for us, when we talk about human biases in data, we're talking about reporting bias, selection bias, overgeneralization, out of group homogeneity, and so on. And when we talk about human bias in collection and annotation, we're more talking on the sampling side and non-sampling side, the in-group bias, bias by blind spot, and so on. Okay? Uh, so, enough from talking about just the negative sides of that. I mean, the reason that we are going over and extensively on how one can have either ethical concerns, be that in a model, in a paper, or in a system, or bias concerns. There are ways for us to try to mitigate that, and luckily enough, in every single aspect of this on the data, on the knowledge representation, on the models, the evaluation, analysis, and the tests themselves, we do have alternatives. And at least on the NLP community, we see a major effort in trying to make that happen. So, for example, in data, we can use automatic moderation, unveiling social biases, and toxicity, and training data, and you know trying to mitigate the fact that you can report that you can say, hey, this data here is biased toward this direction or that direction. And this will help us to kind of take care of that. So if you have a data that's skewed to a given feature or a given characteristic, it's the first step that you have in order to really, between quotes here in this case, to debias this data, or at least to reduce it. And then on social cultural knowledge representation, learning to represent and analyze how social cultural knowledge manifests in language is quite an important aspect. So instead of just using the text to build your language model, it would be interesting to understand what is the social aspect or the cultural aspect behind that text. Probably a text divides in English. It does not have the same structure as the one, semantic-wise, the same the one text from Brazil, from a Portuguese country, and so on. Also, the modeling. So, new modeling approaches that incorporate social cultural context and are trained explicitly to demote social biases. This is somehow easily said than done, but it's still tangible. So, people can still build models in a way that we incorporate aspects that hopefully will promote a less biased, let's say, model at the end. So let's say you're building a model that um, is is making decisions about text. Uh, let's say it's categorizing texts from certain students, and you want to categorize that from being belong to a certain, let's say, degree, like bachelor students, master students, and PhD students for that matter. And then if you have enough text from all of this, all of these groups, most likely your model will be good in predicting text from all of them. Whereas if you have one of these groups underrepresented, things might get a bit complicated, and your model will probably be biased towards one of these specific, let's say, categories that you have. Also, on evaluation analysis, developing interpretable models or approach to interpret existing models and new approaches to evaluation and categorization of model behaviors. So explainability is a big issue right now in AI and deep learning as a whole. So although those models, they are able to scale quite a lot and are robust enough, their power to interpret their decisions or what those parameters mean for the overall picture is not that easy. So if we can find somehow signals, or at least for now, proxy signals that help us to identify why certain decisions were made, it might help us a bit. So when we talk, all of this talk right now is pretty much to bring you awareness of when you start a project, when you start building something, you should, the very first thing is to understand the data. Data really matters for us. So how skilled is your data given the characteristics that you have? Of course, how they correlate among themselves. Is this data really representing the aspects that I'm trying to convey, and by representing them, am I, by consequence or by direct effect, harming another group? Yes or no? So, also, abandoning single training and testing set from similar distribution is quite advisable. So we want our data to be as diverse as possible. We don't want our data to, be representing one single group or one single preference. Another way to try to mitigate that is to combine inputs from multiple sources. So don't rely on only one source of information. Let's say you were building a language model, and this happens, by the way, with large language models. They often do not rely on one single data source. They use multiple from Wikipedia, Wikitext, uh, Wikidata, Reddit, Quora, and so on. So, and most important, talk to experts about additional signals because specifically as computer science, we find ourselves pitching in on several different areas as we understand that area completely. But this is quite hard to say, right? I mean, uh, let's say you're trying to devise, I don't know, you're trying to define a machine translation tool for a specific low resource language, but you don't talk that with a low resource language. So most likely you're going to be missing specific signals that could be used to help you. And as we said before, although neural networks might be set to write their own programs, they do so towards goals set by humans using data collected for human purposes. If the data is skewed, even if by accident, the computers will amplify injustice in a way that think about all the characteristics that you convey when you're writing a text, whatever that text is. Now multiply that by the number of people in the same situation as you, and then try to condense that into a tool that we use this data to draw a specific category. So this is something really interesting to keep in mind. Um, Another example that I would like to bring, simply because we talk about word embeddings, and then when we're talking about dense word embeddings, more specifically on Word2Vec, we mentioned that the data that you're using, it plays a huge role on the, let's say, on the semantic representation that those vectors have. So I would like to bring this paper from 2017. It's called A Gentle Introduction to the Discussion on Algorithm Fairness. And this here, we have that one nice example of this work here, in which the authors demonstrated that famous word embeddings model Word2Vec actually contains implicit gender bias. I find this troubling because numerous applications now use trained Word2Vec embeddings as the first pre-processing stage in their machine learning pipelines. This means this bias is being propagated on a daily basis. And this is actually quite true if you look to the data perspective. If you look to the algorithm perspective, it's a bit different, and this is worth the discussion. So if you take a look on this also, you see another paper going in a similar direction, saying that, hey, we show that even word embeddings trained on Google News articles exhibit female-male gender stereotypes to a disturbing extent. This raises concerns because their widespread use, as we described, often tends to amplify these biases. We provide a methodology for modifying an embedding to remove gender stereotypes, such as the association between the words receptionist, female, while maintaining desired associations, such as between the words queen and female. And this is just to show that, and we'll see what are those actual stereotypes. At that time, when Word2Vec was proposed, a lot of people were using those pre-trained models quite similarly to what is happening nowadays with large language models such as BERT, BART, T5, Pegasus, now ChatGPT, Bard, and so on, by using those pre-trained, let's say, embeddings, those pre-trained weights, you're carrying out whatever stereotype it was there before. And although nowadays the concern about trying to clean this data with respect to ethical aspects is more prominent, in the past, that was not that much of a concern. People just train their word embedding models, and that's how it is. In their findings, they had some extreme she and he occupations where, when you were trying to do the correlation between vectors, such as that example from King, if you take the vector from King and you subtract the vector from man and you add the vector of woman, you have something close to the vector of King. Queen, sorry. And why, when using this association between those vectors, and you try to find correlated ones, you in this work you would find that usually with women you would have something like librarian, nanny, nurse, bookkeeper, hairdresser, and so on. Whereas for men, you would have applications such as maestro, philosopher, warrior, captain, architect, boss, and so on. Although the discussions about this paper and the other one they were quite heated on the actual algorithm, the data concerns that they had it was relevant, of course, as of course the concern about the bias on the actual algorithm, but in this case specifically for Word2Vec, the algorithm is more agnostic than one would think. So and then of course they try to provide some gender appropriate she and he analogies to substitute analogies that at that time people judged completely biased and not well thought. And why we're bringing this discussion for two specific aspects. The first one, the difference between a data bias and algorithm bias. These are completely two different things, and also about the concern of people when they're using, let's say, pre-trained models to the quality towards the quality of the data these models are used, or more importantly, how these models are being used for a lot of people, and they're multiplying whatever bias those models have. But in any case, I guess it's important again not to misinterpret the facts and perpetuate wrong conclusions, because uh, most of times people will claim that a certain algorithm is biased or is being unethical, and of course this can happen if you have something like, hey, here we have if a certain person has a specific value for an attribute, let's say we give a lower credit score for that. This is clearly a biased algorithm in case this attribute here correlates with, let's say, specific personal characteristics. But in that matter, the data issue, at least on this paper, was a bit more concerned because, as we said before, garbage in, garbage out, in a way that if you have a data that represents, let's say, she occupations with this upper part right here, and the, let's say, and this same data, he occupations are this bottom here, you cannot expect anything more from the model than replicating this, unless, of course, when the model replicates or when the model is ready, use some sort of technique to try to eliminate these extreme cases and substitute that for something a bit more democratic or realistic that we have. Um, Also, in the previous example, there was an issue with the similarity metric that was used at that time, simply because when you're doing this difference between word and vectors, the way the difference is defined in most of the APIs is that the resulting term has to be different than any of the original terms that was used to do this operation, right? For those working specifically with media and trying to build language models based on some sort of agnostic task, uh, you should be aware that there is no such thing as neutral text. I mean, there might be some sort of balanced text, but completely neutral, I'm found to believe that this is actually not true. So let's say if you were to train a language model in which our extracted corpus was based on articles, how would you think that would affect the system you can use? And this is particularly interesting because media channels, they do produce a lot of content, textual and visual, and this resource is there for us to use. So depending on which one you use, you can see that you might be inclined into a specific spectrum on the political aspect than others. So imagine that you have a language model that was trained to be more liberal or more conservative, being more extreme liberal or more extreme conservative, imagine the repercussion that you might have if you use this specific language model. Let's say to suggest text completion for you, most likely your text completion will pretty much replicate whatever bias that you have in this data in which was trained. Just to show some examples how different medias they portray, how different media channel they portray different aspects. In this case right here, we have that depending on the media that you're using, you see that they have something like, hey, we have Army, Navy, and Air Force. We have reporting guidelines what people should use, press briefings, and the other people here say we take out, suppress, dig in, and our men are boys and lads. Whereas depending on the other spectrum that you see for the same news segment, you might find that although they're talking about the same thing, you see that reporting that they have a war machine, censorship, or propaganda. They want to destroy, they want to cower in their foxholes and so on. And this happens both ways, right? Every time we have the we versus they reporting and any sort of media that follows a more extreme agenda, as we can see here, you always see the we be put as more, let's say, neutral, allegedly, whereas they are also always reported as some sort of extreme, either for the right or for the left, and all the spectrum between them. The good thing is people are concerned about all those aspects that we're talking about. So consistently, even before 2017, but I would say starting 2017, 18, things are really getting traction. And there is a lot of people concerned about how to use models to make decisions, for example, in the medical domain, or how language models being used, they should be probed more detail in order to mitigate possible bias there and so on. So when we talk about data bias mitigation and inclusion, how we can cope with that? We are talking about things that we should be aware, but how we actually solve this thing. And we're going to head out in this direction right now. After portraying this entire scenario, we'll try to explore some alternatives that have been trying to deal with this, let's say, bias mitigation, inclusion, and ethical aspects and models. So for bias mitigation, we can try to remove the signal for problematic output, and this is actually done today. If you look closely, in the past when the first ultra-aggressive models, the most capable ones, of course, when they were proposed, you would see that they would output some text that it would be considered as offensive or would harm a certain group of people. But now they try to remove the signal output in a way to cope with the output, to cope with this biased output. Of course, this is not a solution because the data and the model itself, they still have all the weights representing this allegedly biased aspect. Also, identifying stereotypes and get rid of them, the bias in our text. These are all, let's say, actions that we can do in order to mitigate bias. Also, on the other direction, adding signals for desired variables or underrepresented variables might be a good way to have more inclusion. Sometimes simply because it's the nature of the data that specific aspects are not represented. So one way to cope with this is to produce either artificially or somehow semi-artificially data to include there. But then, and this, of course, I took from Margaret Mitchell presentation a couple of years ago, and she said that more data is good, but diverse data is even better. And I actually believe with that. It's a really good way of thinking about things. So let's not just think on trying to represent the majority, but try to represent all, let's in this case, all the aspects that we can. This will make things more diverse and probably better. So a couple of things to remember. We're gonna use these things to remember to kind of lead the way for solutions being applied today. So we should question why should we build an LP or model X and how it may harm. So every time, and I would say this even starts before the actual solution. It starts on the research questions. After devising our research questions, try to think what are the implications that by answering those questions will affect whatever personnel that you're trying to categorize in this case. So always be mindful of various sort of biases in the NLP models and the data that they have. So be aware that, and this goes really into the data set reporting in the case that be aware that how your data looks like because it will be biased one way or another. Also, consider this exercise as not of a one-time thing or as a done state. This is a process that requires a lot of iterative process. So when you talk about the questions or data being used, you have to revisit this over and over again in a hope that this will help us to mitigate even more ethical aspects, ethical problems against that. Exploring the biasing techniques, but we have to be cautious not to change the meaning of something, and also it's quite tricky to say the bias because most likely you are inflecting the bias into a different direction. But more important than that is actually reporting what kind of bias so we can identify them. Um, Identify fairness interventions that matter for your problem. So how to make your model more accessible, better representative, and so on. And be transparent about your model and its performance in different settings. So this is quite important. So in which scenarios your model perform with the accuracy, in this case, that you're reporting. So is and in which setup your model was put into practice, and this actually gave the outcome that you're reporting. So as people know in which situation, let's say your data has a specific distribution with respect to amounts and quality and length and so on in a group of people, and then if we know these aspects, we can say, well, this model has this percentage of false positives and false negatives on this specific setup. If my setup doesn't match that, most likely this model will not be the best choice for whatever problem that I have. And in going this direction, we'll talk more about the how how some approaches can be used to try to mitigate unethical and biased aspects and when we're using AI systems and tools and models. Okay. After seeing the ethical aspects, bias aspects that are related with models, data sets, and technologies, now we'll start taking a look on what are some of the measures or let's say approaches used to try to either mitigate, report, or try to make sure that the proper use of AI is being at least taught in the different aspects on the different steps of the process of any project that you might have. Before we go into the actual alternatives that we'll explore in this session, we should take a look first and kind of recap some concepts. So, first of all, before we talk about how to properly report the use of AI. Probably we should define what is AI. I don't think we ever defined that in this class, but AI is a broad field of computer science focused on creating machines that can perform tasks typically require human intelligence, such as visual perception, speech recognition, and decision making. And this includes a bunch of different subfields. I mean, here we're focusing more on natural language processing, but AI is a bit more than this. It's machine learning, robotics, engineering, and so on. And needless to say, that we see AI power tools and AI applications along a large spectrum of different areas, such as in healthcare, finance, transportation, customer service, and the way that they are used, some are more explicit Like if you have a machine, for example, a machine learning model that makes a certain decision giving a certain data set with characteristics, or it can be as simple as your spell corrector that suggests a better word given the context that you're using. So this is a bit more of an implicit use of AI. And that being said, I mean, because it is present in so many different layers in our daily lives, this also comes with some sort of risks, right? I mean, the ones that have we have been talking today are more associated with bias and ethical concerns. So AI can perpetuate and amplify existing biases and discrimination, especially if those are trained on bias or incomplete data sets. And we saw a couple of examples. If you have a data that replicates, let's say, an extreme political opinion, either for right or left, and you use this to train our language model, most likely your language model will perpetuate the same things, and most likely it will be amplifying these characteristics. Also, a risk involving in using AI is regarding privacy violations, as AI can collect and analyze large amounts of personal data, and that raised the concern for us. Okay, if the system has access to all this data, is this data, first of all, was collected with my consent? Now, who has access to that? Another concern that usually comes along with AI being used more and more nowadays about job displacement, and in fact, and this will make this class a bit more. We'll put a timestamp on this class, but recently OpenAI released a report saying what kind of job positions might be in risk given the last advancements of their language models. But in any case, AI applications, as in any sort of technology, can automate certain jobs, leading to job displacement and potentially make things more equal than before. Because if those that are educated and they are practitioners and using those AI tools, they will thrive, while people that do not have such knowledge might be open to some sort of a problem. Unintended harm, as AI systems can have unintended consequences, such as causing accidents or unintended consequences in complex systems, which can lead to harm. That means that when some systems they're not well thought about their outcome, their resulting output or their evidence that helps on the decision making process, they can bring harm to those in specific positions. Let's say we have a system that helps judges to prosecute a person, and for that they analyze their case using a text parsing tool, and they use a machine learning model that was trained in hundreds and hundreds of previous cases, and then they use that to kind of help them to have a final decision. Well, as we know, things kind of have evolved in the past, from the past until today. And what do you think? What sort of bias and problems it would be incorporating this data that these machines are used today? So it will just replicate that, and most likely put some communities in a more of a delicate situation. Also, another risk is, as things get so dependent one another, AI systems can become too non-modular, in a way that if one system fails, the whole chain will fall apart, and that's quite problematic since things are pretty much interconnected. Uh, this is pretty much the downside of it. There's, of course, it's not an extensive list of risks. However, it's also important for us to look to the bright side of things. I mean, AI is not here just to bring harm, the same way the Industrial Revolution also brought a bunch of good things. Why this revolution now would be any different? And for that, is also quite interesting to keep in mind the benefits that we're aiming right now with those systems. So, increase efficiency. For example, we can automate repetitive tasks, allowing us to spend our time in other tasks that are more interested, or they do require some more creative thinking to solve problems. And they kind of release us from doing mundane and everyday repetitive and non-aggregating tasks. Also, it'll help us with improved accuracy. And although this is debatable, depending on the field that you are, AI systems can process a huge amount of data, and that can simply allows us to scale our models and make them more robust, resulting into the improving of some decision making. Innovation, it's quite interesting because AI can enable new products, services, business models, leading to innovation and economic growth. Most likely, there are some implicit pattern on this vast amount of data that we analyze every day that's quite hard for us to understand. But with the use of AI, we can uncover these implicit patterns and pretty much allow things that were not possible before. For example, in protein fold, maybe no one ever thought about combining different proteins and molecules, but because AI can process pretty much everything available, it might find a certain combination that might save lives. So this was probably, it would take years and years to be accomplished. But if you have a tool that is robust enough and is well thought enough, that can help you with that. Not to mention the whole cost saving issue that AI can help companies and people to reduce costs by kind of reducing waste and improving forecasting. By knowing how much resource you need, you don't need to buy more resource than you actually need to store, and therefore we don't waste space, energy, and so on, which is quite interesting. But at least on this portion of the class, we're more interested to look into not only the risks and the benefits. We're not here to assess or judge what is good or bad in the use of AI. We're more concerned on the responsible use of AI. So, and why that? Because as these decisions, what is ethical or unethical, at least with respect to the use of AI, they need time to mature. They need a lot of discussion for us to understand how to responsibly use can be done right now. And then when we talk about responsible use of AI, we are referring to the development and the deployment and use of AI systems in a way that's ethical, fair, transparent, and accountable. So it takes into account the potential impact of AI on individuals, society, environment, and seeks to ensure that AI is used for the greater good. So we want to make sure that the systems, they're being well thought, we know where they're heading, and we can identify when they were used, and we can hold someone accountable for that. And the responsible use of AI is crucial because it ensures that AI is developed from end to end and used to benefit society and avoid harm. The same way we're talking about when we have to think about which kind of research questions we are answering and how their findings and outcome actually can interfere with other people's life. This goes back to the same thing. So how can we design AI systems in a way that it will simply be used for the greater good and not used for any sort of harm? Okay. So, and then we probably should cover some of the principles of responsible AI. When we talk about that, we're meaning fairness. So AI systems should not discriminate against individuals or groups based on their race, gender, or other characteristics. More importantly, it should not maximize, in fact, it should eliminate these risks, especially for groups that are already in a very delicate situation and that they were in a delicate situation for years and years. So we have to make sure that since AI maximizes and scales everything, we can somehow use that not to discriminate against any sort of individual, especially those in the more delicate situation. Uh, transparency. Transparency is the development and use of AI that should be transparent and explainable so stakeholders can understand how the system works and make informed decisions about its use. So it's all about where it was used. So we know exactly what are the components that are being helped by or powered by some sort of AI. And pretty much is about knowing and explaining where things happen. Accountability is with respect to those responsible for developing and using AI should be held accountable for its impact, and systems should be designed with appropriate mechanism for oversight and redress. Usually accountability is mostly related with something goes wrong, but it also can be used to improve things. If you know who is responsible for developing, who is responsible for the use, if something is not on the right track, or if you want to make questions about, you can hold someone accountable, and hopefully the process will be cyclical and you make things better. Also, privacy. AI systems should be designed to protect individuals' privacy and personal data. That goes without saying. I mean, the more we protect our data, the more secure our systems are, and our data is not be used for whatever bad use that we might think. Security of core AI systems should be designed with appropriate security measures to prevent unauthorized access or malicious use. This one is tricky to guarantee, especially when AI systems are part of an entire complex system. You have to make sure that every single point of failure is somehow secure and no one can access or enter your data. However, in order to put all this principle of responsible AI, it comes also with some challenges. Uh, Developing and deploying responsible AI systems requires collaboration and multidisciplinary expertise from a range of stakeholders, not only technical, but also including data scientists, policymaker, ethical teams, civil society organization, government, and everything. Since AI is pretty much touching every single layer in society, the developing using of those systems and the regulation of the systems, it should be a joint effort, simply because when we develop something, uh, it shouldn't be in one single direction that we should look. We should look in all possible directions to make sure that there are no loose ends and we are indeed making the best we can. And the challenge of developing responsible AI, including addressing the bias that we mentioned, ensuring that the systems are transparent, explainable, developing appropriate oversight mechanisms so we can probe those systems and those models to guarantee that they are in check, that they are indeed heading to a proper direction, or they are being used in a proper manner. Um, In short, making sure that all principles are fulfilled and put into practice. These are pretty much the challenges. So if we take a look on all the principles that we just talked about, fairness, transparency, accountability, and so on, to make sure that this is fulfilled, we have to put them in practice. And this is really tricky to do because each and every one of them brings their own baggage and their own complexity. For example, unbiased or mitigating bias is extremely complicated. How you make AI systems transparent, how you report that, how you make sure that you have mechanisms to evaluate the use of those AI systems, and so on. So don't think that it's just a theoretical exercise that people are concerned in computer science. This is actually a practical problem with real world implications, and it should be addressed. Then, but even though there's a bunch of challenges for us there, there are a lot of people thinking how we can make this, let's say, at least some of those aspects solvable. And then researchers and communities are concerned with the current state and future of AI in our daily lives, and for that, they are devising mechanisms that will help us at least to understand when, how, and in which conditions AI systems are being proposed and used in a way that we can track things down. What we're going to do with that is another discussion. Like, we're going to use this to support the use, or to forbid, or to censor the use, or to eliminate, or we're going to use that as a sort of a documentation to make sure that everyone is aware what's happening, and so on. This is a discussion for another session, but at least on the reporting, we do have some really, really interesting initiatives out there. So we're going to go over all of them. We have the data sheets for data sets, the model cards for model reporting, and the ethics sheets for AI tasks. And finally, we also have the AI usage card, which is responsibly reporting AI generated content. And hopefully we'll be able to show you that each and every block of this initiatives they take care of one specific aspect in this entire pipeline of using the data to train our models, to devise our questions. Well, not in that order. First, you devise your questions, you think about them, you collect your data, you design your model, and then you apply the AI model of that. And these are what these initiatives they take care of it. Well, the first one is the data sheets for data sets. It's a framework for documenting data sets using machine learning. And you'll see this quite often on all the other approaches. It's a standardized format for communicating important information to stakeholders about the data set that was collected, pre-processed, cleaned, and make it public or making available. The idea on these data sheets is to increase transparency and accountability and machine learning with respect to data. There are other aspects in these sheets, but the focus more is on the data. And here are the authors that we have. They're not an extensive list of the authors, but we have here Tinti Gebru, Jain, Brianna, Hannah Balash, and so on. But yeah. So what the data sheets for datasets does, they are intended to address the needs for two key stakeholders groups, dataset creators and dataset consumers. So the people that are creating datasets and the people that are using them should be aware of the characteristics of those datasets. So it will make it easier for us to understand and evaluate the data used to train and test machine learning models. For example, we will understand that a given data set was collected during a specific time frame with that specific group of people, with a certain degree of education and so on. It has a certain data distribution with respect to a characteristic and so on. So we collect it. We collect the most possible number of characteristics for describe this data set in a way that we will understand that when a machine learning model is using this data set, we kind of can trace it down and say, well, given this composition of data set, it makes sense that this decision was made, or this data set, this model performs better or worse in specific scenarios, and so on. Not only that, they can also help us to identify and mitigate potential biases in data sets, which can help us ensure that machine learning models are fair and accurate. One might think, well, okay, this is really good for upcoming data sets, but what about those that are already defined? One can still produce a data sheet for a previous published data set if you have access to this data. Of course, the information won't be complete because probably you won't have inside information about the details of the collection, but at least you're going to be able to explain some points there. So what are some of the information contained in these data sets? They do take care about how the collection process took place, in which you have to describe how the data set was collected, including any sampling or data selection criteria, like why did you pick that specific set of characteristics, and most important, the limitations or bias in this data. More important, or as important, saying what the data set is or what is the composition is also as important to say what is this data was not able to provide to us. Also, in this data sheet, they also contain data statistics about the data set. It's a summary of key statistics about this data, such as size, dimensions, distribution, how each characteristic is represented, is the data is skewed into any sort of direction, is there any kind of noises or things like that. Also, what were the pre-processing and cleaning processes that took place when the data was being pre-processed? So, which kind of steps one did between the raw data collection and the data that was actually used in the machine learning model, or the data that was fed into the machine learning model and at the same time was cleaned. So, for example, did we do any sort of stop word removal? Did we remove offensive words? Did we include offensive words because that's important for whatever model we have? Uh, did we make sure to work with word inflections and this sort of things, how the tokenization took place and so on. And of course, in case the data is biased towards any characteristic within the data set or in the data set collection itself, this should be reported. So, for example, the data set was collected given from a given country. So, who collect this data from where? What is the background of that person, or when, if it's not related with the person, where this data was collected, and so on. And this might help us to have a better picture what this data set allows us to offer. This is an example of the data sheets, and this is not an extensive list, of course, but you have an idea. For example, here, they, aside from technical aspects that this data sheet uh, possess, it also talks about some more, let's say, subjective slash theoretical aspects about the data set. For example, for what purpose was the data set created? Was there a specific task in mind? Was there a specific gap that needed to be filled? Please provide a description. Different than other alternatives for this, especially on the AI usage cards, the data sheets, it does require a free text answer for the questions, which it might be a drawback, but it does provide rich details for us to work on. And then another question here, who created the data sets on and on behalf of which entity? This is quite interesting to see who's behind that, who is sponsoring this, who funded this, and things like this. And then, of course, they have more technical questions about the composition of this data, how it's distributed, is there a label or a target that is more represented than others, and so on and so forth. Going into a very similar direction, we also have the model cards for model reporting from Mitchell and co-authors. That's a framework for documenting machine learning models. So whereas the data sheets were more focused on the data collection, processing, and let's say exploratory characteristic of the composition of this data set and motivation and so on, the model cards is more concerned on the actual machine learning models being used. So the idea is to make it easier to understand, evaluate, and compare different models simply because there is no de facto or standard way for you to report your model. So it makes things really, really hard to compare between them. So this approach focus a lot on the technical details about the model architecture and which scenario the model performs with a certain score, its metrics, how it's evaluated, how the model is limited, and so on. Also, they included the ethical considerations related to the models used and which aspects we are applying these models. This is also described in these model cards. So model cards are short documents that go together with training machine learning models that can provide a benchmark evaluation in a variety of conditions. And not only that, this model cards can also provide more details in which specific portions of the data set they perform the way they do. So for example, let's say the model in an overall task is 70%, but they do require you to look closely in this subgroups of this data sets and how this model would perform on that given certain characteristics. They can also help to identify potential bias or limitations in the model, which can help ensure that machine learning models are used ethically and appropriately. Um, Also in the paper, they advocate for measures of the model performance that contain quantitative evaluation results to be broken down by individual cultural, demographic, or other sort of groups, and intersection analysis combining two or more groups and conditions. So imagine that, assuming that you have a good exploratory analysis in your data set, the model cards, they do allow you and they do request you to report how is your model performance in those specific condition with respect to your data. So let's say uh, you're evaluating how coherent a text is, but then the overall performance, as I was saying before, is around 70%, but then that's considering your entire data set. You can do the same analysis, and they do ask you to report the same analysis by breaking down how is this model performance, let's say, on the text produced by people between 20 and 30 years old and more than 30 years old, just as an example. Um, yeah. So, what are some information contained in those model cards? Technical details about the model's architecture and training process. This is particularly important for anyone working with machine learning models. So, what is exactly the input and output? What architecture was used? How it was trained? And all the details on that. Number of epochs, in which hardware, how much time it took, what are the hyperparameters that were, did you do any sort of grid search? What are the values that you did on the grid search to find out best combination possible? When the model performed bad, which scenarios it does perform bad, and so on. Also, the performance metrics and limitations, a description of the model's performance on various metrics such as accuracy, output score, and any limitations or potential bias in the model performances, even, of course, the metrics that you're using. And as we said before, the model cards also contains ethical considerations related with the models used. Um, So this is just to show some of the aspects that the model card has. So on the model details, you do want to have there the person and organization developing the model date, model version, model type, information about the training algorithms, the intention. So who what are the uses and the users of this? What is out of the scope of these models? What are the factors to be taken into account for this model? What are the metrics being used, and so on? So a few possible users for the model cards, a bit different than the data sheets for data sets, where we have data set creators and users. Here, machine learning and AI practitioner, model developers, software developer, policymakers, organizations, machine learning, knowledgeable individuals, and impacted individuals, they all can make use of model cards. And I probably, because this is more of a this model cards goes into a more general use. It got some traction in the past, and actually, it is incorporated in huge institutions such as Hugging Face now. So you do have model cards at Google, and also you have a way to kind of semi-automate the generation of the model card by using this toolkit. Again, talking about Hugging Face, when now you try to upload a model there, they do require you to provide model card for that model, which is quite interesting because it's kind of a way to enforce that if you want to make use of this platform that they offer, please provide all the details that you can. And of course, if you have models that do not have such details, you most likely will be averse of using those models, because if something goes wrong, where whatever you're applying that model, if something goes wrong there, you want to know what exactly was composing that model so you can explain how things happen. So here an example of a model card for smile detection in images. Here we have that this year was developed by the research at Google and the University of Toronto in 2018, version 1. Was pre-trained for face recognition and fine-tuned with cross-entropy loss for binary smiley classification. And then we do have the report of their results by false positive rates, false negative rate, false discovery rate, and so on. So instead of just reporting that probably went on the actual paper with one single result, as that here is the smile detection in images. Here they break it down also for the characteristics that they have for the data set. So not only the metric is broken down, but also some of their categories. And then here you have all the other details that this model has, right? Going into a more non-technical direction right now, we have the ethics sheets for AI tasks from Saif Mohammed from 2021, in which the goal of this AI sheets are the tasks, are the questions we should be asking ourselves when we are automating certain tasks in order to have it a more performatic result or something like that. In this ethics sheets for AI tasks, Saif tried to clarify the assumption and the ethical considerations hidden on how a task is commonly framed, and in the choices we make regarding the data, method, and the evaluation. The use of these sheets is even broader than the ones that we saw before, so researchers, developers, educators, policymakers, politicians, people whose data is used, society at a large scope. And the main idea in this year, the main contribution is trying to describe the recent efforts regarding how we compose tasks that we evaluate. So in computer science, more specifically in AI, we are always facing a bunch of tasks that we're trying to solve, and trying to automate somehow. The AI sheets try to help us to think about this task that we're trying to either propose or automate, and to make sure that they are thought in a way that, okay, who is being affected by the automation of that? Who can be at harm? Who is there any minority or any individual that is it can be exposed to that? And then on this direction, this paper presents a detailed proposal that fleshes out the assumptions and the ethical considerations hidden on how this task is commonly framed, and also the choices we make regarding the data, method, and evaluation. So not only the task, what kind of models we think that would be able to solve these tasks, the data, all of this on the ethical aspects is being considered. The entire paper considers around 50 ethical considerations, with the task of automation and motion recognition as a running example. There is another paper also from Saif that look into sentiment analysis using the ethics sheets for AI tasks, which is pretty cool. So just to give you an idea, overall idea, what are the points that the ethics sheets cover in this task's entire life cycle. On the theoretical foundation, it takes into account the design and the framing of the tasks, the model, their implications, meaning aggregate versus individual prediction. So how, by solving this task, what kind of personnel and does it mean? How does it affect other people, and so on? The automation, if we automate, first of all, if we want to automate a task, why do we want that? And the goal is not only to question if this should be done, but also why we're doing that. It's the mental exercise that we devise on questioning why something is being done already allow us to think about potential problems that might arise. So it also touches diversity, design, its misuse, and so on. What kind of data is being used? What are the dimensions of a certain task? what are the labels that can be used, and all with respect to data. Although the data aspects are better covered, and not better covered, but more focused on the data sheets for data sets. What are the people involved in those tasks? Are their data being anonymized? Are we using crowdsourcing? What are the bias? What are the terms of service that these people should be aware before signing on to these things? What are the methods, metrics, implications, and all sort of things? Now, going to the direction of how this data sets, if we think about all these proposals that we just talked right now, we're more concerned on first looking into the data set, and then we also look at the model, then we evaluate the ethical aspects of that, and all of them, they do have their value and they are complementing part of each other. But what about the use of the system itself? Especially now with the AI assistant tools being used to provide text or provide feedback on a text and improve whatever content that we might have, one question that arises, and it's already part of a lot of discussion in scientific venues, is how AI is being used. So in this direction, we have the AI usage cards responsibly reporting AI generated content from Vale and co-authors here in our group. And then we devised a standardized tool to report using AI in scientific works, but the use of AI and also the frame that we give, it can be used for any sort of work involving AI. Our method was pretty much inspired by the scientific method, but its report can be used by anyone pretty much. On top of that, we also thought how we can make our system a bit easier to use. So for that matter, we create an online questionnaire that's completely free of service provided by the University of Göttingen, and it can be exported. This questionnaire can be exported in a machine readable format that can be incorporated directly into any scientific work. Not only that, by providing this machine readable format, we also provide the source code of the questionnaire and also the actual card in the LaTeX font. So you can, let's say, if you have specific needs, you can take that card, adapt to whatever need you have, and then you will be able to better describe the AI usage in your work. So this, a bit different than the others, we are also proposing a theoretical model in a way that we believe that the responsible use of AI is only possible if we look into three dimensions at the same time. So if we have transparency, accountability, and integrity, then we can refer to a given AI system being used responsibly. And we can think about this model some sort of a three-legged bank or chair. In case that you don't have one of those legs, the entire model probably would crumble. So the first topic or the first aspect that we want to see in our theoretical model is transparency. And as the other approaches, we are focusing on how we can acknowledge the use of AI models in someone else's work. So one should document every instance of using these AI models in a way that we should know and should report, or most importantly, we should disclose where a given AI model was used. For example, I use a spell checker, or I use a tool such as ChatGPT to improve my introduction or to summarize my related work. So we know where and how it was used. And if you think about it, such practice is pretty much already used, at least on scientific papers. When an agent is providing a fund to a paper or to a group, we usually give that into acknowledgement sections, or we disclose that information. So why not do the same with something or some tool that's actually doing this for us? And this will allow us to have traceability of the scientific process steps in which the AI contributed. So with that, we'll know exactly where AI was used. Integrity is more related on the correctness and truthfulness, fairness, safety, and how appropriate the content generated by the AI systems were, in a way that we, as users, we have to make sure that while it's quite hard for us to, let's say, do the fact checking on the actual data that was used or even in the model, we as a user of whatever system, we should be able to say, well, this information here, I'm asserting that I agree with that, or no, I don't agree, it's false and I'm not using it, or it's almost correct and then I'm rephrasing or I'm improving that. And then the idea is pretty much for us to be the middleman there in a way that we can filter out things either to improve or to eliminate propagating misuse or biases. So the idea of integrity is that the user using this technology should be able to prevent some sort of bias being propagated over other people. And that, of course, is related with ethical aspects. You don't want to use a tool that's just outputting some harmful content and you are agreeing with that. While, as we were saying, while it's pretty hard for us to make the model do not choose specific stereotypes and unethical outputs, other than actually cutting those outputs, we as a middleman or as a middle human in this process are able to do this fairly simply per se. And of course, this verification of fairness principles has to be carried out, as we're saying. However, there are some approaches that try to cope with that with some sort of, let's say, post-processing evaluation. So if the model produces harmful content, you can actually train a classifier that prevents this of outputting, but we believe that the person doing this should be let's say, the most important piece in this process. Otherwise, the model, you can simply copy and paste whatever the model outputs and you should be fine, which is definitely not the case. And then accountability goes into the same direction that we had for the model cards, that is concerned on how the researchers use, publish, and disseminate content produced with the help of AI models. And the idea of having someone held accountable for that is that we are able to trace it down who generate the model and who use the model. And also, I mean, when we talk about accountability, as we were saying before, most of times we associate that with the fact that if something goes wrong, someone has to pay the bill. That's actually true. However, this can also be used to improve whatever output we have, whatever model we have. So by having someone accountable in this process, we're able to provide some feedback in a way to improve those models and make changes if necessary. And of course, no one is free of errors. So in case, I don't know, an output was not properly observed or a data set was not properly curated and something slipped through this, the idea is to have someone that is able to go back and try to make things better. So, and without accountability, knowing what was manipulated can produce harm to individuals and does not lead to liability. Then, by having these three aspects here, transparency, integrity, and accountability, we approximate ourselves to the most to responsible use of AI. Of course, there are other aspects that should take into account, but for our model at this point in time, we believe this is a really good alternative. It would be interesting to see how this work evolve and age along the way. I mean, how many times do we have a model that was published at that time was the best model in that given task, but give it some time and we see how things evolve. So as we were saying before, each dimension is crucial for using AI in a specific process. And think of that as a three-leg chair in a way that, let's say, by acknowledging the use of models and holding authors accountable, the output can be explained, but it might still contain some inaccuracies and bias since no verification steps have been taken. So it is the responsibility of both the AI user and creator to provide sources for the ideas presented, allow the readers to verify them. Is the same thing on the model. So we have to acknowledge where this model was used. If we acknowledge the usage of AI and improve its content, we achieve usability, but can encounter a lack of accountability if problems occur. So we know where it was used. We know that someone approved that, but we don't know who approved that, or who devised the model, for example. Then that can definitely be a problem, such, for example, in plagiarized content or misleading information and so on. So by having acknowledgement and approval of the content can be used at our own risk due to the lack of accountability in a way that you can use, but no one would take responsibility for the outcome. And then when we have accountability and integrity verified, the output is secure because it has been affirmed. Still, we need to know where the use occur or when the model was kind of applied. Therefore, if we consider the acknowledged use of the model or the AI tool, we mitigate its inappropriate outputs, or we make sure that we are propagating things that are ethically adequate and factually correct, and assign someone to take responsibility in case problems occur or simply questions arise. Then we can mitigate major issues in AI and make its use more responsible. And here we have a link that you can play around and design your own cards. And after you design that, our system will generate a LaTeX template that will send to your email, right? And how this model was taught, as we were saying in the beginning, when we present this model, the AI usage cards was inspired in the scientific process in a way that we took the scientific methodology pipeline in which we thought about is a good basis for us to track where things took place initially. So we talk about we have information about the project details as any other alternatives that we just explained. We cover ideation and review. So was the model used to support doing theoretical preparation of the project through idea formulation by outlining something or examining related work? Methodology and experiments. So was the model used to design, compare, or generate process based on specific instructions or not? And then which of those were actually resulting in some sort of experiments? And then on writing and presentation, and this takes a huge portion of the AI usage cards. So generation and paraphrasing of text using in scientific reports or papers. So the improvement of a content, figures, tables, and any other elements are also included when we do the disclose of that information. Code and data. So did we generate any code, manipulate, refactor, optimize? Did we process any sort of data with these AI tools? And of course, we do have an ethical component about it. So the implications of using AI and steps to mitigate their possible errors and harms, we're also interested on that. And giving all this six big blocks that we have, from project ideas to ethic considerations, uh, a couple of different aspects are considered for every one of them. So in every single aspect of the scientific methodology right here, and actually this is important to mention before we move on. This is the initial version of the model, the AI usage cards. By providing the source code for the user, we are encouraging that this card is not only used but also expanded to specific needs, because it is the current version, it is based on the scientific method. But what prevents this to be incorporated on, let's say, on funding agencies to track down how much an AI system was used during the writing of that grant or the project conceptualization? Or let's say we want to use the AI usage cards on the medical domain. For sure, the current version does not provide the necessary details for that, but by having access, and we welcome users from this system to provide new versions of these cards. So this is actually something really nice that we have. So in all those steps into the scientific process, we're mainly concerned with three different aspects. So we are concerned if a new content was generated based on prompts without significant portion of prior ideas. For example, generate some ideas on how to approach the problem of memorization of large language models. So we provide instruction in a way that I'm expecting this model to return with an entire, let's say, set of instructions or a set of information that will answer to that instruction. And then another aspect that we cover in the AI usage cards is the revision of content. So given that a text generated by humans or not is provided, can we did we use the AI model to improve that, or to paraphrase that, or simply to reorganize ideas? For example, we provide a prompt. If you provide a prompt, rephrase the following paragraph so that it uses academic voice, is concise and short, and add an example of a meta-analysis. So, and of course, after that, you would provide whatever text you have. So not only we are concerned about tracking when things are generated, but we are also concerned about how things are reassessed, either by either as this text is provided by humans or not. And in the last aspect, we are also tracing down how a content generated provided, or how content generated by two or more pieces of content, they can be compared. So either if you compare your own work or your own definition with another one, provided or not by the machine, if you did something like this, this use should also be reported. So, and this opens to some interesting evaluations, right? If you can compare different answers from the same model or from different models, or you can compare different authors, original text, and so on, this is also being traced down. Okay, given all this given all these alternatives, in order to proper disclose the use of AI in our lives, in our work, in our projects, how the data was composed, how the model performed in specific categorization of data or specific distribution, or how certain tasks they were provided, or which AI tasks we were playing around, we might think that if we can report data sets, the models, the tasks, and the AI content itself, we have achieved responsible use of AI, right? I wish we could say yes, but not really. At least we are trying to get there. I mean, all those alternatives that we just saw, they're a result of a long-standing work, and I mean, they were inspired also by other works. But the thing that things are actually taking form now, it actually is a nice. It's a nice aspect because people are not just sitting on the problem; they're trying to find solutions. Especially now with this rapid use of AI everywhere, AI models, machine learning models, AI assistant chatbots, and so on. But then don't think that by using all of this, your work is done. Simply because all these tools, all these approaches, they do have limitations and they do require that some sort of effort to make them, let's say, better. For example, the adoption of all of them, it takes some time. I mean, imagine one has to report all the scars in their work, so it is quite complicated. It depends a lot on the context. Some high stakes scenarios, they should still be considered if the use of AI is actually proper there. Uh, all of them, since they require the person using these models to be active in the reporting, they are error prone, intentionally or not. So either if you want, even if you don't even notice, most likely uh, you are probably going to make mistakes. Let's say you reported the wrong version of your model or you used the wrong distribution in your data. So these things, they happen. Also, as we talked before, they do require an active or proactive participation. So it's not that simple. At least we're trying, which is a good thing. And I mean, we are. I'm listing this limitation here. This some of these limitations, not to discourage, much to the contrary, that you can think about this and how we can make these limitations less and less prominent. Well, all in all, much progress has been made, and I'm sure that much more will still be. It's just a matter that if we stop for a moment, think and act, right? That being said, here are the references and some slides that I adapted my talk from. And thank you very much. Bye.